All right, you guys, welcome back. In today's section, we're going to be covering section 2.5, which is entitled Variation. Okay. At the completion of this lesson, you should be able to complete the following objectives. So, one, we're going to be able to construct a model using direct variation. Two, we'll be able to construct a model using inverse variation. And three, we're going to be able to construct a model using joint variation or combined variation. Okay. So the first question you may be asking, what is variation? Okay. So anytime you have a mathematical model, all right, and it's developed for a real world problem, it involves relationships between quantities that are often expressed in terms of proportionality. Okay. So some examples of that is force is proportional to acceleration. The force of attraction between two heavenly bodies is inversely proportional to the square of the distance between them, and revenue is directly proportional to sales. All right, so of these three examples that they gave, probably the one that you're most familiar with is probably the last one, which says that revenue is directly proportional to sales. So we all know that revenue is the amount of money you make after you have sold something, right? So revenue is the money you make. Right? And we all know that sales is the amount that you sell. All right. So what this is saying, if it's directly proportional, direct proportion means that both of those quantities are moving in the same direction. So the more money you make, so as revenue increases, that means that your sales must have also increased. So we know the more you sell, the more you make. It also means that if your revenue is decreasing, then your sales must have decreased also. So direct variation means that your two quantities in question are moving in the same direction. When we get to inverse, they'll be moving in opposite, and joint means you have two or more variables moving in different directions. All right. So in this section, we're going to be talking about three different types of variation. All right. So in short, variation means how one quantity varies in relation to another quantity. So we're going to be looking at direct variation, inverse variation, and jointly. Okay. So let's look at those definitions for those three different types of variation. So the first two, all right, so in direct variation, so the formal definition says let x and y denote two quantities. Then y varies directly with x, or y is directly proportional to x if there's a non-zero number k such that y equals k times x. The number k is called the constant of proportionality. Okay. So if we're looking at this picture right here, this is exactly what that example was talking about when they were saying that revenue is directly proportional to sales. So in this case, our sales would be on our x-axis because it's the thing that we are manipulating, the thing that we are changing. And then on our y-axis here would be our revenue. So this is telling us that as sales increases, as I'm in my X position and I am moving to the right, I'm increasing, then my Y value, which is my revenue, is also increasing. So direct variation, is when both of your variables are moving in the same direction, whether they're both increasing or they're both decreasing. This is the model that we will use. Y equals K times X. Okay. And this constant of proportionality, it tells us by how much one variable is changing when we move the other. All right. Now, in inverse variation, okay, it's going to be a little different. So inverse variation says let x and y denote two quantities. Then y varies inversely with x, or y is inversely proportional to x if there's a non-zero constant k such that y equals k over x. So if you have this example, all right, it means that as you are increasing one variable, the other variable is moving in the other direction, which means that it's going to decrease. So an example of this would be, let's think about it. So the more kids you have, the less spending money you may have. Okay, so for example, as the number of kids we have would be on our x-axis, okay, then the amount of spending money would be on our y-axis. All right. So as we increase the number of kids we have, the amount of spending money we have is decreasing. So when you have inverse variation, your two variables in question are moving in opposite direction. So for direct proportion, they were moving in the same direction. For inverse variation, they're moving in different directions. Okay. So direct, same direction. Inverse, different direction. Okay. Now for the last one, we had direct, inverse, and we also have jointly. Jointly just means that you have more than one variable acting together in your problem. All right. So if you ever have a problem where you have joint variation, you could have two variables that are jointly affecting another one, or ones that are inversely affecting. So you could have two direct, two inverse. You could have a direct and an inverse. It just means you have a combination of variation happening in that problem. All right. Awesome.